Okay, 9.1 day 1, we're doing an introduction to the trigonometric ratios, which you have used at least 3 of these before in geometry. Okay, so the 6 trigonometric functions are sine, which we abbreviate as SIN, but we still say sine when we say it. Cosine, COS, tangent, TAN. Okay, and then we have cosecant, which is abbreviated CSC, secant, abbreviated SEC, and cotangent, abbreviated COT. Okay, and now to learn sine, cosine, and tangent, some of you learned SOHCAHTOA, which is still appropriate and still works. Okay, sine of theta, according to this triangle, is going to be the opposite side over the hypotenuse side. And for SOHCAHTOA, that's sine equals opposite over hypotenuse. The opposite side is if I start from theta, that's the opposite. Hypotenuse is opposite the right angle, and then the adjacent side is the one that's next to theta, but is not the hypotenuse. Cosine is the adjacent over the hypotenuse. So from here, it's this side over this side, and the answers are ratios or fractions. Okay, TOA. Tangent is opposite over adjacent, so tangent would be this one over this one. Okay, now if you have not heard of cosecant, secant, and cotangent, they're just reciprocal functions. So the reciprocal of sine is cosecant. Since sine is opposite over a hypotenuse, cosecant is hypotenuse over opposite. They're reciprocals. Okay, the reciprocal for cosine is secant. Since cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent, and the reciprocal for tangent is cotangent. So instead of opposite over adjacent, it's adjacent over hypotenuse. The thing to notice is that the function and its reciprocal do start with a different letter. So sine goes with cosecant, cosine goes with secant. Okay, the second column are sometimes called reciprocal trig functions. And that's because we saw that cosecant was the reciprocal of sine, and sometimes we write that as 1 over sine of theta. For secant, that's a reciprocal of cosine, so we say 1 over cosine theta, sometimes when it's convenient. And then for cotangent, it was the reciprocal of tangent, so that's going to be 1 over tangent theta, and they're called reciprocal functions because they are the reciprocals of the 3 main trig functions. Okay, we're going to look at the triangle, and we're just going to label the ratios. Okay, so they gave me a triangle. They want me to do the functions of theta. It matters where theta is. Theta is a Greek letter, by the way. So don't worry about what I say, just match the letter. And it makes a difference where theta is because that's how I label my sides. So from theta, the opposite is over here. You don't have to label them, but I am, so we can make sure we're getting them right. Okay, so I have the opposite side. Hypotenuse is the longest side, or it's the side opposite the right angle. So right angle, hypotenuse is over here. Which means the leftover side is the adjacent side. The adjacent is always a leg. Okay, I want to do sine. What is sine? Sine is opposite over hypotenuse. You don't need to write the letters, but it's just to remind us. What's opposite? Opposite's 5. What's hypotenuse? Oh shoot, I don't know it. So we're going to use Pythagorean theorem to figure out the hypotenuse side. So let's do 5 squared plus 12 squared equals, what letter should we use for hypotenuse? Okay, let's use h squared or c, something like that. Let's square root it. What's the square root of 169? 13? Okay. So the hypotenuse is 13. So now I do know the hypotenuse. The hypotenuse is 13. So sine is going to be 5 over 13. Okay, cosine is a over h, or adjacent over hypotenuse. The adjacent side is 12. The hypotenuse is still 13. Tangent, TOA. TOA is O over A. And you don't need to write O over A. I'm doing it for your notes. Okay, O is opposite. 5 over 12. Done. And if any of these simplified, I would simplify them, but none of them simplify. Now we get to the weird ones. The weird ones are the reciprocals. So cosecant, what is cosecant the reciprocal of? Cosecant is the reciprocal of sine. Do I have the answer for sine? Sine is 5 over 13, so cosecant is going to be 13 over 5. Okay, what is secant the reciprocal of? Secant's the reciprocal of cosine. So instead of a over h, it's h over a, so it's going to be 13 over 12. Cotangent is a reciprocal of tangent. Since tangent's 5 over 12, cotangent is 12 over 5. Okay, let's try the next one. And I'm going to mix up the order because sometimes we memorize stuff without memorizing it. Okay, this symbol's phi. It's a Greek letter. It doesn't matter as long as it matches. Okay, but I need to start from where phi is so I can label the opposite, adjacent, and hypotenuse. So the opposite side is over here. It's the 8. What's the hypotenuse? Hypotenuse is opposite the right angle, which is over here, which means that leftover side is the adjacent side. And the problem is adjacent side blank? The adjacent side is blank. So I'm going to use Pythagorean theorem to find the adjacent side. Okay, so I'm going to call it A. A squared plus 8 squared equals 10 squared. Okay, I'm going to minus the 64. Okay, so what do we got? Adjacent side is 6. So let's give it a 6. Okay, now let's go ahead and do our ratios. Okay, tangent, TOA. So O over A. That simplifies. Let's simplify it. What does it divide? I can divide the top and bottom by 2, so it's going to go to 4/3. And you should simplify whenever you can simplify. Okay, what's cosine? So, ca. A over H. A is 6. H, 10. Simplifies by 2 3/5. Okay, sine is so. O over H. 8 over 10. Simplifies, yes. Okay, now be careful on the reciprocal ones because I have mixed them up. Okay, secant is the reciprocal of cosine because they do not have the matching letters. So when cosine is A over H, so instead of A over H, I'm going to do H over A, which is 10 over 6. Now if I simplify that, what is that? That's 5/3. Okay, the other way I could do it is say, okay, secant is the reciprocal of cosine. Here's my answer for cosine. I got 3/5, and I could flip the simplified answer, and that would give me the 5/3. So if you happen to have one answer, you can use that to get the next answer. Okay, cosecant is the reciprocal of sine. Different letters. Sine is O over H, so this is H over O. So H is 10, O is 8. If I simplify it, I get 5 over 4. Okay, and again, I could have said, okay, this is a reciprocal of sine. I could have looked at my answer for sine and then flipped the answer, and then I wouldn't have had to simplify it. Okay, cotangent is the reciprocal for tangent. So instead of OA, it's A over O. A is 6. O is 8. And if I simplify it, I get 3/4. And then just like with the other ones, I could have also just said a cotangent is the reciprocal of tangent. My answer for tangent was 4 over 3, so if I flip it, I get 3 over 4. Okay, let's look at C. That little symbol that looks like a fish is called alpha. So from alpha, this is the opposite. Hypotenuse is opposite the right angle. Adjacent is the side over here. Don't have to label it, this is just for my notes. Are we missing a side? We're missing the opposite side, so let's do Pythagorean theorem. 2 squared plus the opposite squared equals 5 squared, and you know, O is not the best variable because it looks like a 0. But that's okay because I already started. Okay, so O squared equals 21. Let's square root it. O equals, can I simplify square root of 21? 3 times 7. No, I'm going to have to leave it as square root 21. So this is going to have an irrational part to it. Okay, now I've mixed up the functions again to make sure you know which one's which. So secant is the reciprocal of cosine because they have different letters. So cosine is A over H. So this is H over A. Okay, what's H? 5. What's A? 2. It simplifies? No, it's good. Okay, now cosine is A over H. What was A? 2. h 5. Okay, or I could have said, oh, cosine and secant are reciprocal, so if I know one answer, I can flip it and get the other answer. Now cotangent, what is that? Reciprocal of tangent. So instead of O over A, it's A over O. A is 2. What's O? Square root of 21. Okay, now there's a problem with this radical. And the problem is we cannot leave a radical in the denominator. So we're going to have to rationalize the denominator. Okay, so if I don't want a square root of 21 at the bottom, to cancel it, I multiply by the square root of 21. Top and bottom. Okay, what's this going to give me? 2 times the square root of 21 is 2 square root 21. If I do root 21 times root 21, I get root 21 squared, and the squared and the square root cancel, and it goes back down to 21. So this is the answer they would like you to give. 2 root 21 over 21, because you can't leave a radical at the bottom. Okay, let's keep going. Okay, sine. So over h. So that's root 21 over 5. Is this okay? This is fine. There's no square root on the bottom, so they like this answer. Tangent. TOA. Root 21 over 5. Is this fine? Oh, it's not over 5. It's over 2. Hold on. Is it fine now? Yeah, this is still fine. There's no square root on the bottom. Why do I have sine twice? What am I missing? Let's change this to cosecant. Okay, cosecant is the reciprocal of sine, so that's going to be h over o. So h is 5. O is root 21. Okay, is this one fine? No, I cannot leave the square root of 21 at the bottom. Multiply by root 21, root 21. So I get 5 root 21 over 21. Okay, let's look at the next example. It says, let theta be an acute angle in a right triangle. Acute is less than 90. If it was more than 90, it wouldn't be in a triangle. Or at least not in a right triangle. Use the given trigonometric ratio to find the remaining 5 trig ratios. So all they're going to tell me is one trig ratio. So in this case, they're telling me cosine theta equals 4 over 7. Most people find drawing a picture is helpful. Some people can do it without the picture. Okay, for cosine, what's cosine? Cosine is adjacent over hypotenuse. So this is the adjacent side, this is the hypotenuse side. So if I were to sketch a picture, your triangle can go any way you want it to go. I do need to I have to put theta in a corner. 4 is the adjacent side. So from theta, the adjacent side is 4. The hypotenuse is 7. Okay, now I need the missing side so I can find the rest of the trig ratios. So I'm going to go ahead and do Pythagorean theorem real quick. So that's 4 squared plus x squared equals 7 squared. Okay, if I minus 16, I get 33. Okay, so the missing side is the square root of 33, and that's the opposite side. Okay, if you choose not to draw the triangle, I'm fine with that. Some people just, you still need to do Pythagorean theorem to find the missing side. Some people note that this is the hypotenuse, and then they can set the equation based on the hypotenuse. Okay, so now let's write the ratios. Okay, sine is opposite over hypotenuse. Okay, what's tangent? TOA, opposite over adjacent. Okay, cosecant, what's cosecant the reciprocal of? Cosecant sine. So sine is O over h, sine is h over o. Or since I have the answer for sine, I can just flip this upside down. So I'm going to flip it upside down, and I'm going to get 7 over square root of 33. But we cannot leave the square root of 33 at the bottom, so I'm going to multiply by square root of 33. And if some of you can do it in your head now, you would probably do something like this. I would go, okay, I'm timesing by square root 33 on the top. If I times by square root 33 on the bottom, square root 33 times square root 33 turns into 33. And this is my rationalized answer. Okay, what's secant? Secant is the reciprocal of cosine. We know that cosine is 4 over 7, so secant is going to be the reciprocal Cotangent is the reciprocal of tangent. So let's take our tangent answer and flip. And then because I can't leave a radical at the bottom, we're going to rationalize it. If I multiply by root 33 at the top, I get 4 root 33. At the bottom, root 33 times root 33 turns into 33. Okay, let's try one more. Okay, last one. Cotangent of theta is 15 over 8. Okay, tangent is opposite over adjacent, so cotangent is adjacent over opposite. So I'm going to draw it this way. You can draw it differently. Okay, so adjacent is 15, opposite is 8. Some people also will flip this. They'll say tangent of theta equals 8 over 15, and then they will draw it that way. Okay, I need my missing side, so let me solve it real quick. Okay, if I square root, it actually comes out nice, it's 17. So hypotenuse is 17. Okay, now let's see what we got. Secant, oh, we're starting hard. So secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. The hypotenuse is 17, adjacent is 15. Okay, cosine. Well, cosine is the reciprocal of secant, so if secant is 17 over 15, then cosine is 15 over 17. Or I could do adjacent over hypotenuse and get the same answer. Okay, what's tangent? Tangent is TOA, opposite over adjacent, or I could take my cotangent and flip it. So I get 8 over 15. Sine is opposite over hypotenuse, which is 8 over 17. And cosecant is the reciprocal of sine, and since sine is 8 over 17, cosecant is 17 over 8.